Hi, I'm Adam. Welcome back to Godot Game Lab. In this video, we'll take a look at a SceneSpawner component. Designing components can be as easy as asking three important questions. What is that one thing that the component can do very well? What data does the component need to do its thing? And finally, how does it communicate with the outside world? Let's answer these questions for the SceneSpawner component itself. So what is that one thing that a SceneSpawner component does? Well, it spawns a pack scene to the current scene tree. Simple as that. But the question is where? Where do we want to spawn that new instance? By default, we'll spawn it under the SceneSpawner's parent node, but we can also spawn it under any custom node for convenience, or even at top level to make it independent from all the other nodes in the current scene, which is very useful, for example, for bullets. The next question is, what data does a SceneSpawner component need? It needs a pack scene to spawn, which will be an export variable, and it also needs a parent node to the new instance. An important side note here is that the parent node is actually optional, as it defaults to the SceneSpawner component's parent for convenience. Now, how does this component communicate with the outside world? We'll have two public methods. One is called instantiate, and this method does not add the new instance to the scene tree. Instead, it just returns that new instance. This is useful when you want to execute code before the new instance is added to the scene tree and its ready virtual method is called. On the other hand, spawn, the other public method, instantiates and adds it to the scene tree immediately before returning the new instance. Notice that here we have a parameter called parent, which will be the parent node, and that equal sign means that if you omit that parameter, the getParent method will be called, providing that default value we talked about. Now let's move on to implementation. We start with an add tool annotation because the component shows node configuration warnings when there is no pack scene selected. For this, the script needs to run inside the editor, hence the tool annotation. Then a custom icon is provided which makes the component feel like it's part of the Godot ecosystem when you create a new node. And finally, a custom class name is set and the class is extended from the base node class. Then an export variable is defined for the pack scene resource. The custom setter function calls update configuration warnings after setting the new value, so the editor can check if the correct node type was set for the variable or if it's set at all. Then two Boolean export variables are defined for spawning top level. If top level spawn is true, the new instance will be spawned independently from all the other nodes. Match transform top level is only used for top level spawning. If true, the new instance will copy the transform, the global position and the global rotation of the parent node despite being spawned independently from it. This is useful, for example, for spawning bullets. You want it to spawn from a muzzle point, but you also want it to move independently from the character which has that muzzle transform, right? Next, we override the built-in getConfigurationWarnings method, which returns a pack string array with all the warning messages. There are two cases to handle here. If the scene export variable is either null, or it's set to something but it's not a pack scene, we return a warning message that no valid scene was assigned to the SceneSpawner. Otherwise, the correct export variable is set, so we return an empty array. Next, we have the instantiate public method, which is the easier one to define. It starts with a safety check. If the export scene variable is not set, return null. Otherwise, we call packscene.instantiate, which creates the new instance, and we can return it from this method. The final part is the spawn public method definition. Notice how the parent parameter is optional and it defaults to node.getParent. Then the pack scene is instantiated with our newly defined instantiate method, and the new instance reference is stored in a variable. Then a copy of the parent parameter node reference is created and stored as spawn source. We need that later for top level spawning. Then, if spawn top level is true, the parent is set to the current scene, ignoring any other nodes in the current scene tree. When the parent is finally decided either way, we add the new instance as a child to that parent reference with node.addChild. Then comes the trickiest part. If both match transform top level and spawn top level are true, we need to copy the transform of the node that we originally wanted to use as a parent. This is why we made a copy of it, the spawn source variable, before overriding it to the current scene. Copying the transform means setting the new instance's global position and global rotation to the same values. However, Safeguards are needed here. We need to make sure that both the spawn source and the new instance have a global position property before we can safely set it. The same is true for the global rotation. Now, why do we need that safeguard? Well, it's all about flexibility. We need to make sure that the SceneSpawner is as versatile and flexible as possible. You can spawn nodes, node 2Ds, node 3Ds, and control nodes with it. All of them should work, right? But not all of these kinds of nodes have a global position or global rotation values, so we make sure that the component is foolproof. Because nodes don't have global positions or any transform properties at all, and these safeguards make sure that even if you toggle those booleans, it doesn't throw an error message. To check for those properties, we use the in operator. And before we even get to the comments, I know that some people will say that you shouldn't use strings like this because it's error prone and such, but I don't think Godot will ever change in that sense that these properties will be called global position and global rotation. For this purpose, to make it foolproof, I think it's fine to use those strings and the in keyword to make sure that they both have those properties before copying. And the final line of code we need here is actually returning that new node after instantiating it and adding it as a child under the correct parent, and if needed, after copying the transform from the original parent candidate. That's it for the implementation part. Now let's see how we can use this in action. If you like my content, please consider checking out my Ko-fi page where you can donate one time or become a member and get early access to all my content and videos. This is the example scene setup we have. Notice that the scene tree is quite long because all three examples are within the same scene. We have the flames demo, which is this one, the projectile demo, and the reward demo. For the flames demo, we have a node 2D called flames, and we have 5 markers for the positions where we want to spawn those fire particles. Now to do that, we added a SceneSpawner node, which is set up in the following way. We only set the pack scene export variable. We don't need to spawn it top level or match any transforms because we want to spawn them under these flame spawn marker 2Ds. And for 2D nodes, when you spawn one under the other, it inherits its transform by default, right? So all we need to do is to set that export variable to the flame. If we open that scene, you can see that it's just a particle effect with no script or anything attached to it. So now if we run this test scene and I click the spawn flame button a couple of times, you can see that it will be spawned under those marker 2D positions. And if we take a look at the remote scene tree and check out the flames demo, you can see that it's spawned under that marker 2D node. And if we scroll all the way down, you can see that the position and the rotation is set to 0. But it appears at the correct position because the marker itself has its position set. Now, what do we do in the code? How do we use the SceneSpawner? Because it just provides that outside communication line, right? So if we check out the Flames demos script, we have an already variable reference with all the marker 2Ds inside the scene tree. And we have a variable that keeps track of how many flames we currently have. Now, if we press that button, we check if that's the demo that we are currently looking at. And it's pretty simple. If we already have 5 flames, we need to wrap it around and start from 0. So we reset it to 0 and just queue free all the particle effects that we have spawned under those marker 2Ds. And regardless of how many flames we currently have, we spawn a new one using that array for grabbing the parent and add one to the flames variable. Now you see that we only need to use one line of code to actually spawn in that new fire, and we don't even need to store the returning particle node because we don't want to do anything with it. So it's super simple to use that spawner component. Now another use case would be for spawning projectiles. So we have the projectile demo, the second one, where if I toggle it on, we actually have a character, and if we take a look at it, zoom in a bit, we have the sprite, we have a weapon, and the weapon has 2 hands and the bow attached to it, and also a muzzle. This is a marker 2D, and this is where we want to spawn projectiles when we press the fire button. We also have a timer because I wanted to showcase that the character can move independently from the projectiles. So the timer is used so the character bounces back and forth between the 2 edges of the screen. And we have a scene spawner for spawning projectiles. Now you see we set the scene to the projectile scene that we want to use, but we also toggled both spawn top level and match transform top level to true. If we open up that scene, we have the projectile. It's pretty simple. The script that we have attached to it is just, it uses its rotation and moves with a constant speed based on its current rotation, and if it exits the screen, it deletes itself. Pretty straightforward stuff. Now this is what we want to spawn in, and we want to spawn it from the muzzle's position, but we also want it to move independently from the player. The script that we have for the projectile demo is pretty straightforward as well. Let's take a look at it. We have a direction and a character speed for the character itself, and when the timer times out, we multiply the direction by -1 so it changes, and we listen to the input for two reasons. One is when we press the fire action, then we want the SceneSpawner to spawn a new projectile at the muzzle. So notice how this is a very different use case for the SceneSpawner, but it's still a one-liner. Setting the parent to the muzzle in this case means that we want to spawn at that position, but it won't be spawned in the scene tree directly under the muzzle, right? It won't be spawned here because we override that behavior with setting the spawn to top level. So instead it will be spawned under the root of the current scene. But since we also enabled match top level transform, this muzzle position will be used to spawn it at the very top. Another event that we listen to is the mouse motion event, because we want the character's weapon to rotate towards the mouse's direction. So we use a mouse aiming mechanism for the character to aim his bow towards the direction where he wants to shoot his bow. And the final thing we do in the process, callback or virtual method, is that we translate the character's position towards the direction that it currently is moving towards. Now, this is a very common use case for spawning stuff, especially for projectile firing when you want it to be top level, but you also want it to be convenient, right? So with that one component, it's still a one-liner for both cases, which I think is pretty cool. Now, if we go back to 2D view, let's hide the projectile demo so we can use the tabs to navigate between the different demos. Switch to projectiles, you can see the character moving, and when I aim my mouse, the bow gets rotated, and if I press space, I can shoot arrows towards all directions. Now, another interesting thing is when we take a look at the remote scene tree, when I spawn them, you see that they are getting added under the root node of the current scene, right? It's not at all connected to the character's weapon's muzzle. So when we set it to top level, this is what I meant by independent spawning. Now, another interesting thing is when we select the SceneSpawner, let me show you what happens when we don't toggle this match transform top level. You see, it doesn't really matter where I aim. It's correct that the arrows will be spawned independently from the muzzle, but you see at the very top that they will be spawned at 0, 0, which is the top left corner of the screen, and since their default rotation is just 0 towards the right, they will shoot at the same direction always. Now, if we toggle spawn top level off too, what happens is that the arrows will be spawned directly under the muzzle, which means that they have the correct direction and position. But if I keep aiming, the already shot projectiles are affected by it, which is not at all what we want for these types of weapons, right? Hopefully this makes you understand why we need those toggles. And the final use case that we have for spawning is that sometimes we want to execute code before adding the new instance to the scene tree. And in those cases, we have to do the adding part manually. Now, why would we need to ever do that? Let's take a look at the reward demo example. We have a SceneSpawner here. And you see I didn't set anything except the scene that we want to spawn. And if we click open, this is again a GPU particle 2D node, but it does have a script attached to it. And it also has an export variable called level. Now what we do here is we have different levels of rewards, and we want to spawn some kind of diamonds indicating that we got some reward. And the amount of particles we make is based on the level. And also we have different process materials attached to the different levels, and also different texture regions from the sprite sheet that we have. So the diamond texture that we use for spawning the particles will be different for each and every level. You see that we have this logic and setting emitting to true and auto deleting the reward itself. They are all executed inside the ready. And this is absolutely fine. I think this is how it should be done, because then you can test this scene independently, right? So if we go back to 2D view, maybe move it a bit away so we see what happens. And if I just run this scene, you'll see the particle spawn and it deletes itself. So I can test how it works. I can set the level to 3, for example, and rerun the scene. And I can see that it's different. Diamonds are bigger and they have a different color and there are more particles spawned when I change the level, right? That's always what we want, testing the scenes independently. Now, the problem that we have, if we go back to 2D view, we can reset the position. The problem that we have right now is if we were to use the SceneSpawner, this code will be executed before we can change the export variable from the outside. Why? Well, because if we take a look at spawn, this method right here, we instantiate the new reward scene in this case, and after deciding its parent, we actually add it to the scene tree before returning it. And that is super important because this happens before we actually access it from the outside, right? So whenever we call this spawn method, we return the node so we could change the level property, but by that time it's too late because it was already added to the scene tree, triggering its ready virtual method. Now this could be circumvented. We can do something like extracting out this functionality, leaving the ready empty, and we can create a new function and call it something like init or setup or something like that. And this is actually something I did in the past in my tutorials as well, but I kind of find it janky. I think it goes against the philosophy and the flow how Godot nodes work, right? It makes it much easier to test, and also in a sense it's more pure because you don't need extra methods for basically nothing, because what we really want to do is execute this code when it's ready, right? I don't want it to belong to a different method, it's just a technicality. So yeah, it could be solved in that way, but I don't really like it. I think it's much cleaner to say that, okay, we know that sometimes you want to do this and the spawner can still be used. It's less useful that way, but it can still be used for that purpose as well. How? Well, if we go back to the SceneSpawner demo scene, take a look at the SceneSpawner, we just assigned it as an export variable, right? But the demo script itself, which is important. We have a level variable, and when we press the button, this is the code that we need. If we use the instantiate method of the spawner instead of the spawn, remember it doesn't add it to the scene tree, it just returns the new instance. And then if we save that to a variable, we can change the level property and manually add it to the scene tree wherever we want it to. We can use any parent node and just reference that node that we changed after instantiating it. So this is how we can inject code before adding it to the scene tree. We cannot use the spawn method for that, but that's why we provided that instantiate method as well. So if we take a look at this in action, switch to the reward tab, the current level is set to 1. If I click on the button, the first level will be spawned. If I press space, we move to level 2, we have the red diamonds and a couple more. We go to level 3, we have the golden diamonds and much more of them as well. Hopefully this was useful. I think this is a very, very versatile component, and it might not seem like that at first glance, but it saves you tons of lines of code, which you would otherwise rewrite over and over again for all the projects. And again, I want to emphasize that putting these safeguards in means that you can use it to spawn any kind of node in Godot. Nodes, no 2Ds, no 3Ds, and control nodes as well. That's why we put it under the general category. And that wraps up the SceneSpawner, but before we go, something I forgot to mention in the previous video is that we have the GitHub repository for this course, and we have 2 folders. And you cannot see this folder inside the Godot editor if you download the project, because I added a gdignore file to it. But a while ago, I started a voting process about documenting these components. And if you take a look at the components folder, this is what you can see inside the Godot editor. So if you go to SceneSpawner, this is the code that we just went through. But in the components Docstring folder, we have the same code with full Docstring documentation as well. You notice that it seems and feels much longer and more convoluted as well, but it's really useful if you prefer documented code for your projects. So if you want to use the Docstrings version, you can download those versions as well from the repository. Now, if you never used Docstrings before, what does that mean? Let me show you. If I just replace the code with the Docstring version and save the whole thing, what I can do now is press F1 to open up the help window. And if I search for SceneSpawner now, you'll see that all the Docstring code that I provided makes it searchable. So we have these, it spawns the scene into the tree, the node to use as a parent, etc., etc. So if you prefer documented code or you want it to be searchable from the help menu, you might prefer the Docstring version. In the videos, I will always use the undocumented version to make it look less intimidating, but I just wanted to highlight that this is available as well. Now that's it for this video, and I'll see you in the next one. Bye-bye.